Hey all, have a good day. I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, let us see about bipolar junction transistor configurations. So a transistor is also called as a bipolar junction transistor or simply BJT. It is called as a bipolar as only two types of charge carriers, that is a majority charge carrier and minority charge carriers, are required to perform the operation of a transistor. BJT is a current control device as the output voltage, current or power is controlled by the input current in the transistor. As we know, BJT is a three-terminal device, so there are three configurations: common emitter, common base and common collector, which has its unique characteristics and applications respectively. As the transistor has three terminals, any of these three terminals could be connected to form the common input and output terminal. Depending upon the terminal which is used as common terminal, there are three types of transistor configurations: common emitter, common base and common collector. So first we will see about common base configuration. So in this type of configuration, the base terminal of the transistor serves as the common terminal. So it is called as a common base configuration. The input voltage is applied between base and emitter terminal. The output is taken between the collector and the base terminal of the device. Common base configuration has low input resistance but high output resistance. Current gain is in the common base configuration is denoted by alpha. It is defined as the ratio of collector current to emitter current. So alpha is equal to collector current divided by emitter current. As the collector current is always smaller than the emitter current, so the current gain alpha in the common emitter configuration is always less than unity. So this is a diagram which shows the common base configuration where the base terminal is grounded and it is in common between the emitter and the collector. So here we have emitter base junction and collector base junction. So emitter base junction will be always forward biased and collector base junction will be always reverse biased. Next one is the common emitter configuration. So this type of configuration is called as the common emitter configuration, as the emitter terminal of the transistor is made as the common terminal. The input voltage is applied between the base and the emitter terminal of the transistor. The output is obtained between the emitter and the collector terminal. Common emitter configuration has the low input resistance but very high output resistance. So current gain in the common emitter configuration is denoted by beta and it is given by collector current divided by base current. As the value of collector current is much larger than that of the base current, so the current gain in the common emitter configuration is very large, greater than unity. So the value of beta ranges here from 20 to 300. So this is a diagram which shows the common emitter configuration. So here the emitter terminal is in common between the base and the collector. So on the input side you will be having base emitter junction and on the output side you will be having the collector emitter junction as shown in the figure. So here you can also relate relationship between alpha and beta, where alpha is equal to beta by 1 plus beta or beta is equal to alpha by 1 minus alpha, where alpha is equal to current gain in the common base and beta is the current gain in the common emitter configuration. Next one is common collector configuration. So this type of configuration is called as common collector configuration, as the collector terminal of the transistor is made as common terminal. So the input voltage is applied between the base and collector terminal of the transistor and the output is obtained between the emitter and collector terminal of the transistor. Common collector terminal has a very high input impedance but low output resistance. Current gain in the common collector is denoted by gamma and it is given by emitter current divided by base current. So this is the diagram which shows the common collector configuration. So here collector is common in between the base and the emitter, and the input side is has base collector junction, and the output side has emitter collector junction. So here also we can relate gamma to alpha and beta. So gamma is equal to 1 by 1 minus alpha, or gamma is equal to 1 plus beta. Some advantages of transistor configurations are: for common base configuration, it has low input and output impedances, which is used to drive the loads of different impedances. This type of configuration offers low power consumption, and the current gain of this configuration is less affected by the change in temperature. In the common emitter configuration, it has high power gain, which could be used when both current and voltage amplification is required. So this type of configuration is easy to bias and therefore offers versatility to various applications, and it also produces inverter output. Next one is the common collector configuration. So in this type of configuration, the voltage gain is close to unity, which could be used for buffering of voltages, and it has high input impedance, and no phase reversal between the input signal and the output signal is achieved here. Let us take up some assessment questions. For a BJT, for common base configuration, the input characteristics are represented by a plot between which of the following characteristics. So in the common base configuration, you know that the input side is the emitter base junction. So we will be having the input characteristics as will be plotted between the voltage of the base emitter junction and the current of the emitter junction. So VBE and IE is the correct answer here. Which of the following correctly determines the relation between alpha and beta? So as we know that beta is equal to alpha by 1 minus alpha. For the common emitter configuration, which of the following is the correct relation? So for common emitter, we know that IC is equal to IE. Thank you for watching this video.